Okay, how's it going, guys? So today we're going to be talking about periodic table of elements and how to read each individual element on the table. And then in later episodes, we'll talk about some of the main rules of the periodic table that it follows. Okay, so this is a smaller screenshot of the element oxygen, and the first main part that you see is the name of the element. So in this case, just oxygen. Now the next main thing is the letter, and some elements have two letters, some of them have one, and that just is the atomic symbol. In this case, it's an O for oxygen. Okay, so the next major thing is if you look at the top left corner, it has the number 8, and that has to do with the atomic number. And what that represents is how many protons are actually in the nucleus of the element. Now, this is seen in the picture listed with the red circles represent protons, the green circles represent neutrons with no charge, and the light blue, smaller circles represent electrons. And the electrons have a negative charge, the neutrons have no charge, and the protons have a positive charge. And this represents oxygen because if you count them all, there is 8 protons, which means that any atom with 8 protons is oxygen. Doesn't matter how many neutrons, doesn't matter how many electrons. Now, another main idea that you might kind of come across is, well, what does it mean that it's the same element, but if you change some characteristics of that? And one major change would be changing the amount of neutrons in the nucleus of the element, and that's actually called an isotope. An isotope is the atoms with the same number of protons, meaning it's the same element, but different number of neutrons are present. In this case, it's helium, so you have one helium proton for each. So they're both considered helium, but they're both different isotopes of helium. And finally, the bottom number under the atomic name is the atomic mass. Now, atomic mass is interesting because you can actually look at it different ways. So if you just only look at the separate isotope of one select isotope of an element, you're going to count out the amount of protons plus neutrons plus electrons of only that isotope. And you get a very usually defined number. On the other end, if you want to get what it shows on the actual periodic table, you get the atomic mass for every single isotope, and then you average mass for the isotopes based on the abundance of every isotope. And this is seen in oxygen because the number is 15.999, which means that the isotope that has a mass of 16 is the most abundant, while the other ones are less abundant. Finally, I want to close off with the next episodes that are coming up. So I'll be talking about different types of bonding, ionic and covalent, and I'll be talking about naming compounds based on those bonds.